All right, folks, what we want to do today is we want to look at balancing redox reactions in acidic or basic media. So as we're going through and considering these two different conditions, remember whenever we talk about acids, we're looking at it dissociating into H plus and then the anionic component. And whenever we first encountered bases, we look at having an alkali or alkaline earth metal. Then that key piece is that hydroxide group. So let's go ahead and look at balancing these. So whenever we have a redox reaction in acidic media, this is really what's going to help us balance both acidic and basic. They're more or less the same steps. There's just one extra step for if it's in basic media. So the first thing is, like with any redox reaction, is you want to be able to write your two half reactions. And whenever you write your two half reactions, you're going to break up everything and you're not going to worry about the hydrogens or oxygens to begin with. So we'll balance typically metals. Then after that, we'll go through and balance the oxygens by adding water. But then since we've added water, now we've also added hydrogens. So to balance out the hydrogens, we have to add protons, H plus. But now we've changed the charge on one of the sides of our reactions. So now we need to balance the charge as well. So we need to add electrons. Then finally, what we're going to see is, like whenever we had two of the half reactions, we have to go through and multiply so we have the same number of electrons, and then after that you can cancel out anything that's on both sides of the reaction and be left with your net reaction. So that sounds like a lot, so let's just go ahead and do a couple examples. So here what we have is we have that dichromate ion plus Fe2 plus yields chromium 3 plus iron 3 plus. So let's go ahead and start by separating out the metals and writing our half reactions. So I will start by writing out, we have Cr2O7 with a 2 minus charge, going on to form Cr3 plus. And then we also have iron, which is Fe2 plus, going on to form Fe3 plus. All right, so that's the first step, is to write those two half reactions. Now what we need to do is we need to go through and balance everything but oxygen and hydrogen. So luckily for the case with iron, it's already balanced. But with chromium, we have 2 on the left, so now we need to add a coefficient of 2. So we have 2 on the right. So now that's balanced. Okay, so now it's time to balance oxygens. So again, iron doesn't have any oxygens that we have to worry about balancing, so we can ignore that. But with this reaction with chromium in it, there are 7 oxygens on the left-hand side of the reaction. So we need to balance that by adding 7 waters to the right-hand side of the reaction. Okay, so now we've balanced the oxygens, but we've also introduced hydrogens. So to balance the hydrogens, we're going to have to add protons to the left-hand side. So we're going to add 14 protons, so 14H plus. So now we're in the case where all of the atoms are balanced, but the charges are not balanced. So in order to balance the charge, we're going to have to add electrons. So as we look at this, we can see that on the left-hand side of the reaction, we have 14 plus from the protons, and then 2 minus, so that gives us a total of 12 plus on the left-hand side. And on the right-hand side, we have 6 plus because we have 2 of the 3 pluses. So to balance the charge out, we're going to add electrons. And in this case, we're going to add 6 electrons to the left. So that will take this charge that was 12 plus down to 6 plus. All right, so now we also need to look at iron. So in the case of iron, there's a 2 plus charge on the left-hand side, a 3 plus charge on the right-hand side. So we're going to add electrons to the right-hand side of the equation. Whenever you're balancing these equations, you should always be adding electrons to opposite sides in the half reactions. If you ever add electrons to both the products or to both the reactants of the half reactions, that means that you've probably done something wrong, and it's best just to start over to make sure you don't make a silly mistake. So now that we've balanced the charge, what we need to do is we need to balance the electrons of each reaction by multiplying by a coefficient so we can get the least common multiple. So in this case, we have 6 electrons in the first reaction and 1 electron in the second reaction. So we're going to go through and multiply this whole second reaction by 6. So then what we can do is we can go ahead and combine these reactions. So we have 6 electrons from the first reaction plus 14H plus Cr2O7 2 minus. And then in the reactants in the bottom reaction with iron, we have 6 Fe2 plus. And that yields, now we can write all of our products. We have 2 Cr3 plus 7 H2O plus 6 Fe3 plus 6 electrons. Now, as we go through and start canceling out things on both sides, the only thing that's common on both of these is the electrons. Many times this won't be the case. You'll have to cancel out some waters or some protons, but in this case it's just the electrons. So once we cancel that out, we'll end up with our net reaction, or our overall reaction, which is 14H plus Cr2O7 2 minus plus 6 Fe2 plus, yielding 2 Cr3 plus 7H2O plus 6 Fe3 plus. And again, I would go through and double check that both the atoms and the charges are balanced. So in our next example, we're going to look at balancing redox reactions in basic media. And everything is the same as it was in the case for acidic media, but here, after you add the H pluses, you add the same number of hydroxides as H pluses, but to both sides. So then you can end up forming water on one side and hydroxide on the other. And then you carry on canceling out any waters that are there and also balancing the charge with the electrons. So let's go ahead and try an example. And it's easiest just to try it by doing examples instead of talking about the theory behind it. So in this particular example, we have MnO4 minus plus NO2 minus yields MnO2 plus NO3 minus. So we need to start out by writing our half reactions. So we need to try to separate out the 9 non-hydrogens and oxygens. So here we have manganese. So we'll have MnO4 minus going on to form MnO2. And then our other half reaction, we will have NO2 minus going on to form NO3 minus. Okay, so now let's make sure that all of the non-oxygens are balanced. So in this case, the manganese are balanced in the first half reaction. In the second half reaction, the nitrogens are balanced. So now that everything's balanced, we need to balance, go through and balance the oxygens. So in the first reaction, the left-hand side, there's 4 oxygens. On the right-hand side, there's 2. So we need to add 2 waters. Okay, in the second reaction, there's 2 oxygens on the left, 3 oxygens on the right, so we need to add a water to the left-hand side down here. So now that we've added waters and balanced our oxygens, we need to go through and balance the hydrogens. So in order to balance the hydrogens on the first reaction, we've added 4 hydrogens to the right, so we will add 4 H pluses here on the left-hand side. And then we added 2 hydrogens from the waters in the left-hand side of the second reaction, so we need to add 2 H plus over here. But now this is where it differs from reaction in acidic media. So since we added 4 H pluses to the left-hand side of this top reaction, we're also going to add 4 hydroxides here and 4 hydroxides over here on the right-hand side. And then in the second half reaction, we'll have plus 2 OH minus here and plus 2 OH minus over here. So what we'll see is the hydroxide and the proton will form water. So we're going to rewrite this with water, and then we'll go through and worry about balancing the charge. So we have 4H2O plus MnO4 minus yields MnO2 plus 2H2O plus 4OH minus. And then down here we have 2OH minus plus H2O plus NO2 minus, yielding NO3 minus plus 2H2O. So what I usually do before I go through and add my electrons to balance the charges, I cancel out any waters that I can. So in the first reaction, I have 4 waters on the left and 2 on the right. So these 2 on the right cancel out completely, and this coefficient of 4 changes to a 2. And in the second reaction, we have 1 water on the left, 2 on the right, so the 1 water goes away. And then this coefficient changes to a 1. So now we're ready to go through and get the correct number of electrons so we can have a balanced charge, because right now all of our atom types are balanced, but the charges are not. So if we look at this in the top reaction, we have a -1 charge on the left-hand side. And then we have -4 on the right-hand side. So that means that we need to add a total of 3 electrons. And in the second reaction, we'll see that there's a total of 3 minus, or -3 on the left-hand side, and -1 on the right-hand side. So we need to add 2 electrons. All right, so now we have the charges balanced within the individual half reactions, but we need to figure out what do we need to go through and multiply by in order to get to combine these reactions into an overall. So, well, what's the least common multiple of the 3 electrons and the 2 electrons? Well, the least common multiple is 6, so we'll multiply this reaction overall by 2. And this reaction overall by 3. And what we'll get whenever we combine these, it's quite long, but we'll have 6 electrons. Okay, so we're starting with this top reaction, plus 4H2O, plus 2MnO4 minus, plus 6OH minus, plus 3NO2 minus, yields 2MnO2 plus 8 hydroxides. I have to go to the second line here. Plus 3NO3 minus, plus 3 waters, plus 6 electrons. Okay, so now we need to combine these. So what we can see is right away the electrons should always cancel out for these. So the electrons are gone. So we have 4 waters on the left, 3 waters on the right. So the 3 waters on the right cancel out. This 4 turns into a 1. Then the other thing you have to watch for canceling are hydroxides. So we have 6 hydroxides on the left, 8 hydroxides on the right. So these 6 cancel out. And this 8 changes to a 2. Then what we should see for our overall reaction is we have H2O plus 2MnO4 minus plus 3NO2 minus, yielding 2MnO2 solid plus 2 hydroxides plus 3NO3 minus. And that is how you would balance a redox reaction in a basic solution.